In the universe, there exists an extremely terrifying celestial body that can devour everything appearing in its strange orbit. Even light cannot escape from it, overturning all of humanity's understanding of physics. This devouring giant hand wandering in the universe is known as a black hole. How exactly was it discovered? In 1783, British physicist John Michell, based on Newton's theory of gravitation and the corpuscular theory of light, discovered a strange phenomenon while trying to determine the mass of stars. He believed that the velocity of light particles leaving the surface of a star would decrease due to the star's gravity. This velocity depends on the size and mass of the star they are escaping from. After calculating using the speed of light measured by O. Romer, he concluded that if a star were 500 times the size of the Sun, the inherent velocity of light particles would not allow them to escape the star's gravity. Such a star would be in an invisible state, detectable only by its gravitational effects on surrounding objects. He referred to such invisible stars as dark stars, which are what we now call black holes. However, at that time, Michell's concept was too advanced and did not attract much attention. It wasn't until 1915 that German astronomer Karl Schwarzschild, using Einstein's general theory of relativity, calculated the gravitational limit of celestial bodies. He posited that when a massive star reaches the end of its life, its immense gravity would cause the surrounding space-time to continue contracting, with the density of the body increasing constantly until space itself becomes infinitely curved. This eventually evolves into a point from which nothing can escape. Schwarzschild, through mathematical formulas, found that when light particles or matter pass through curved space, they encounter a boundary. Once they cross this boundary, they disappear entirely. This boundary, created by the extreme gravitational pull of the black hole, defines its existence. The black hole, therefore, is like a dense celestial body with extreme gravity. To confirm its existence, we need to detect a phenomenon known as gravitational waves. Einstein, based on the concept of space curvature in general relativity, predicted that space might exhibit different degrees of torsion, rapidly propagating as waves throughout the universe. This implies that when two massive celestial bodies, like black holes, collide violently, the resulting energy could be tens of times that of the entire visible universe. This collision would also generate gravitational waves that propagate across the universe at the speed of light. Gravitational wave detectors around the world have been tirelessly searching for these waves as they reach Earth. Finally, on September 13, 2015, a detector successfully recorded this signal from 11 light-years away. This strange sound was the first conclusive evidence of the real existence of black holes, confirming Einstein's prediction of gravitational waves in general relativity. Analyzing the data revealed that the gravitational waves were produced by the merger of two black holes, each with a mass 29 and 36 times that of the Sun. The resulting black hole had a mass 62 times that of the Sun, with the remaining 3 solar masses being released as gravitational waves. From the early days of life on Earth, through the dominance of dinosaurs, and the Ice Age, to the rise of ancient civilizations, gravitational waves have been expanding at the speed of light. They pass through the Milky Way, beyond Alpha Centauri, past Uranus, Saturn, and finally reached Earth 11 years after the collision. To further understand the true nature of black holes, in April 2017, astronomers used 8 telescopes located around the world to observe the same target, collecting data to create a virtual telescope with a diameter equivalent to Earth's. They used ultra-long baseline interferometry to reconstruct the images, with each telescope receiving electromagnetic signals of different strengths depending on its distance from the black hole. Atomic clocks were used to minimize timing errors. After extensive computation, they finally produced the first image of a black hole in human history. It took humanity hundreds of years to capture just one image of a black hole. The mechanism of black hole formation remains an unsolved mystery to this day. Perhaps within the black hole, there exists a completely sealed-off world. Only through deeper research will the secrets contained within gradually be revealed to us.